Hello, this is Pat Kelly. In this problem, they're asking us just to evaluate this integral, and they, of course, do give us the force vector function as well as the path function. Okay, so to begin, what I'm going to do is rewrite this integral that they want from me, and just an equivalent version of it. What it really comes down to is this dr. I'm going to replace with something equivalent. Leave some space. That's the same as r prime of t dt. And what that's going to allow us to do is put everything in terms of t, the parameter, and also here's an r prime of t, and they gave me an r of t, so we'll be able to figure out what r prime is and put it in here. And to finish this equivalent version of the integral, I still have to address my f. The f function was originally in terms of x and y, so I only left a space here because you can't actually just write f anymore. It's going to be f of something that depends on t. You're going to have that same independent variable. And the way we do that is just f of x of t, comma y of t. And then there's the dot product in between. Okay? And to finish off this integral, if everything's in terms of t, my limits of integration are simply the values of t, high and low. So a to b, looking ahead, that's just going to be the 0 and the 1 for us. Okay? Now I like this start to the problem of rewriting it because now you can see the pieces of the puzzle that you need. I already mentioned r prime. We're going to find r prime in a second. And you can also see the other piece of the puzzle is this thing, this f of x of t, y of t. Let's find that as well over here. So r prime of t is just the derivative of this r vector. So the derivative here looks like just 3 times the I, plus the derivative of t is just 1, so plus j. Okay, done there. And the other piece of the puzzle that we said we needed was this whole f of x of t, comma y of t, right? All of that. It's easier to do than to write, I think, that whole expression. Because in order to do this, you just take your x component here from the path function, so 3t plus 1, and you plug it in wherever you see an x up here. Now in my force function here, I only see an x right there and I only see a y right there. But these expressions can get as involved as they want to be. Wherever I see an x, I'm going to put 3t plus 1. So here's a 3t plus 1, and that's times the I vector. And then I'm following this like as if it's a formula. There's a plus. And then here's a y. Wherever I see a y, I'm going to put in this component. In this case, just that t. So t times j. Okay. All right, so what I have in front of me then are both my r prime and also this f expression. So I'm ready to come back over here, and let's do that dot product. Okay, so in my next step, this will equal the integral from 0 to 1 for a and b. Let's do this dot product as we fill it in this line. So this f times, or dot that r prime, I'm looking at these two guys right here. And for our dot product, you're just multiplying the pairwise components and adding in between. So 3t plus 1 multiplied by 3 is going to be a 9t plus 3. And then plus, and you multiply these components, corresponding components of t and 1, so that's just a t, and that's dt. Got your integral looking pretty good, because this is actually going to be a very manageable integral now, right? So let's do this. This equals 9t plus t is 10t. Let's integrate that by bumping it up to t squared and dividing by 2. So the 10 divided by 2 will be 5, plus the 3 is just going to anti-differentiate to 3t. And I do have my limits of integration from 0 to 1. I know you love 0 and 1 at this point for plugging in for values. 5 plus 3 is 8, and subtract 0, we got a nice answer of 8. Okay? That's it for this one. Practice some more on your own.